Rate equations and Kp. Reaction rate definition, the change in amount of reactant slash product per unit time, aka reaction rate is how fast reactants are converted to products. If reactants are in a solution, the rate equals change in concentration per second, and units of that change in concentration per second for rate, moles per d minus cube s to the power minus 1. How to work out the gradient from a curved graph. Find out the point on the curve you need to look at. Place a ruler at that point so it's just touching the curve. Position the ruler so you can see the whole curve. Adjust the ruler until the space between the ruler and the curve is equal on both sides of the point. Draw a line along the ruler to make a tangent and extend the line right across the graph. This is really important. I don't think you should memorize this because all the questions are, they give you a graph and they'll say calculate the gradient from a curved graph, but it's just these key details. So place a ruler at a point, just touching the curve, and you need to position the ruler so you can see the whole curve, and then adjust it so the curve is equal on both sides of the point. That's the really main thing. The rest of it is pretty simple. Tangent, extend the line, find the gradient. Tangent, a line that just touches the curve and has the same gradient as the curve does at that point. Rate equations tells you how the rate is affected by the concentration of reactants. Order reaction, the power to which the concentration of reactant is raised in the rate equation. K bracket rate constant, a number that links the rate of the reaction to the concentration of reactants at a particular temperature. A number that links the rate of reaction to the concentration of reactants at a particular temperature. Why does rate constant K increase as you increase temperature? Increases the number of collisions between reactant molecules and energy of collision, but concentration of reactants and orders of reaction stays the same. Therefore, K must increase for the rate equation to balance it out. Converting data from concentration time graph to rate concentration graph. Find the gradient at various points on the graph, given the rate at a particular concentration for a straight line graph. But if it's a straight line, but if it's concentration, draw tangents to find the gradients. And then you do another graph, rate and concentration, and you plot it. So concentration time graphs is zero, concentration and your time down, concentration and time like that, concentration and time like that, zero order, first order, second order. Rate concentration graphs, they convert into rate concentration time, zero order, rate concentration, that's first order, rate concentration, that's second order. Overall rate is decided by the step with the slowest rate, and that's really important. Obviously, rate determining step is the slowest step, but this key thing, the overall rate is decided by the step with the slowest rate, so the rate determining step. Rate equation, if a reactant appears in the rate equation, it must affect the rate, so the reactant or something derived from the reactant must be in the rate determining step. So in some cases, in exam questions, it won't just be the reactant, it'll be something derived from it. So instead of NO2, it'd be N2O2. Like NO bracket squared, it would be N2O2, something derived from it must be in rate determining step. So you need to be aware of that. If a reactant doesn't appear in the rate equation, then it won't be involved, or something derived from it won't be involved in rate determining step. Catalyst can appear in rate equation, rate equations therefore can be in rate determining step. Rate determining step doesn't have to be the first step in a mechanism, and the mechanism can't be predicted just from the chemical equation. It doesn't have to be the first step, and mechanism can't be predicted from just a chemical equation. The order of reaction with respect to a reactant shows the number of molecules of the reactant involved, and the rate determining step shows the number of molecules of that reactant involved in rate determining step. Arrhenius equation shows how the rate constant K varies with temperature and activation energy. K equals AE to power minus EA over RT. As EA gets bigger, K gets smaller. Why? Well, as a large activation energy, it's going to be a slow rate, as not many of the reactant particles will have enough energy to react. Only a few collisions result in the reaction happening, therefore it's going to have a slow rate. As temperature increases, K increases. Why? High temperatures, therefore reactant particles move faster, more energy, so more likely to collide, and more likely to collide with at least activation energy. Therefore, rate of reaction increases, and therefore K must increase. ln K equals minus EA over RT plus ln A, or you can say ln K equals ln A minus EA over RT, whatever you prefer. Now, I should have made this clear. I forget it. Partial pressure in a mixture of gases, each individual gas exerts its own pressure. That's partial pressure. In a mixture of gases, each individual gas exerts its own pressure. Total pressure of a gas mixture is the sum of all the partial pressures in a of individual gases, sum of all the partial pressure of individual gases. Mole fraction, the proportion of a gas mixture that is made up of a particular gas, proportion of a gas mixture that is made up of a particular gas. Kp, the equilibrium constant for reversible reaction by all the reactants and products or gases. The equilibrium constant for reversible reaction by all the reactants and products or gases. Kp is calculated from partial pressure. Adding a calculus won't affect Kp. It just means we get to be system to equilibrium, gets the system to equilibrium more quickly or quicker, gets the system to equilibrium more quicker, but it doesn't affect the Kp value. And then, all these Kp calculation questions, that's when you do your past paper questions, right? No point of going through example questions. Those questions, Kp, 5 markers, 6 markers, you just need to do a load of practice questions. And they really do like to include Kp. So obviously learn all this on these 2 pages and then practice the calculation questions.